All right, everyone, we're going to start working on endpoint 8, dividing decimals. Now, I would say that of the decimal sections, this one's the most difficult, but only because there's some long division built in. There's really only one step that's different than just dividing regular numbers. Okay, but before we start, I want to talk about this idea of dividing by a decimal and what that means. Okay, so I'm going to stick with the number 10. Okay, that's what I'm going to start with. And if we have 10 and 10 is divided by 10, we should know that that's equal to 1. Okay, and if we have 10 divided by 5, okay, a smaller number, that's equal to 2. And then if 10 is divided by 1, an even smaller number, well, that's equal to 10. And we have to look at the pattern here is that as the bottom number gets bigger, the answer, or as the bottom number gets smaller, the answer gets bigger. Said that backwards. Okay, so then if we start dealing with decimals, okay, so 10 divided by 0.5 or 10 divided by 1/2. If you think about it, okay, what that means is if you're taking 10, you're splitting it into 10 equal groups. Well, there should be 1 in each group. Okay, if you have 10 and you're splitting it into 5 equal groups, there's 2 in each group. Okay, 10 into one group would be 10. Well, if we're taking 10, we're splitting them into 0.5 groups, or half of each in each group, or half of each of 10. Okay, that would mean then that our answer should be 20. And we notice that this keeps getting bigger. Okay, so the one thing that I want you to remember is dividing by a decimal. Okay, makes a number bigger. Okay, and that's important. You should always think that if you're dividing by a decimal, something less than 1, it will make your number bigger. Okay, so estimating is going to be more difficult with these numbers, but it's more important. Okay, it's important to identify, okay, a number that's easy to divide by. So here, we could do 18 divided by 2, and that's a pretty easy number, that's 9. Okay, but hypothetically, if we were looking at 19 divided by 2, okay, that's a difficult number. So that means that you would have to estimate differently. You're always going to be looking for these easy numbers to divide. Okay, so if we're going to be dividing by a decimal, 18.4, and we're dividing by 2. Okay, for these types of problems, if you do not have a decimal here, which in this case we don't, you can just put the decimal up there on top and leave it where it starts. And now we simply do the problem like we had done before. Okay, 18 divided by 2 is 9. 9 times 2 is 18. We subtract, that's 0, and we bring down the 4. 4 divided by 2 is 2, and so our answer should be 9.2, which is very close to our estimation. Okay, so if you only have a decimal in the number underneath this, then it's pretty straightforward. Not a lot of problems there. Okay, but in an example like this one here to the left, okay, it will be more difficult. So here's also a good example of when it's tough to estimate, because if we made this a 3, 50 divided by 3 is not a number that I know. Okay, so I'm going to use a little bit of critical thinking, and I'm going to change this to 2. Even though that's not correctly rounded, it's pretty close, and that means our answer should be close to 25. Okay, so now we have 50 here divided by 2.5. And the problem with this one is we have the decimals over here, and you cannot have a decimal on this number. Okay, you can't do the problem there. So what we're going to do is we're going to turn this into 50.0, which is something we know we can do. And to get rid of the decimal on the left, we're going to move that decimal 1 to the right for both numbers. Okay, so I'm going to move it 1 to the right here, but I also have to move this 1 to the right. Okay, so now our decimal's here, and we're going to bring it up there. Okay, from this point, we're now going to do this as if we're dealing with 25 and 500. Okay, which is something we can do. 50 divided by 25, well, 25 can go into it twice. So we get 50, 0, and bring a 0 down. Well, 25 can go into 0 0 times. So our answer is 20, which is pretty close to our estimation of 25. Okay, so there are two types of problems we've got to look at. If we have a problem like the first one, okay, where there is no decimal here, we just take the decimal and we move it up. In a problem like this, where we did have a decimal here, we need to take it and move it 1 to the right for both numbers. Now, if there's 2 decimals, you'd have to move it twice. 3, you'd have to move it 3 times, and so on and so forth. So for this one here, we have 28.74 divided by 5. Now, we do not have a decimal here, so we're fine. We'll put that decimal here. For our estimation, I have to think of a number that can be divided by 5 that's close to 28.74. The number that comes to my mind is 30. 30 divided by 5 is 6. So our answer should be near 6. So how many times can 5 go into 28? 5 times. It's 25. It becomes 37. Well, 5 can go into 37 7 times because 5 times 7 is 35. So this becomes 24. That can go in 4 times. And we have a problem. We have a remainder. In this situation, since we're working with decimals, we're going to add on a 0. And we're going to take that 0 and we're going to drag it down. So that becomes 40. And then we're going to extend our radical here. That can go in 8 times. So our answer is 5.748, which is very close to 6, which was our estimation. Okay? Try a couple more here. How are we doing on time? I don't want to get this too long. About 8 minutes. So we're going to cruise through these last 2 and then move on. So this one we have 728 divided by 3.2. Now we have a decimal in the wrong part. We have a decimal here. So that means we're going to add and make this a decimal, and we're going to move them both 1 to the right. So now we have 32 and 7,280. So the decimal goes right there. This can go in twice. That makes this 64. Makes this 88. This can go in twice again to make this 64. 240. Now it gets a little bit tougher. Okay, so how many times can 32 go into 240? Well, this becomes 32, 64, that's twice, 96, that's 3 times, then 128, whoops, wrong button, 160, 192, oh, we're getting close, 224. So 1, 2, 3, 4, 5, 6, 7. Let me double check to make sure my math is good. 32 times 7 is 224. Okay, so that goes in 7. 1. And now we have a problem because we have a remainder, so we're going to add in a 0. We're going to bring it down. 160. Well, if we look over our list, since we already did this once, we have our number 1, 2, 3, 4, 5. And so our answer is right there, 227.5. Okay. This one here we have 96.9 divided by 6.8. Now we have a decimal in both, so these are actually the easiest. We have to move this 1 to the right, and the decimal goes right there. So 68, that goes in once. So 289. So I get 68. 68 times 2 would be 136. We're going to add 204 and then 272. Okay, so 1, 2, 3, 4. This becomes 170. It feels like I made a mistake. Let me double check. 68 times 4, 272. Nope, that's right. So now we add in a 0. 170, this can go in twice, which becomes 136. So we get 3, 4. We're going to add in a 0. And now if this doesn't work this time, we're just going to be done and we probably made a mistake. But we know that if we add in another one here, it ends up working out nice. So this will be 1, 2, 3, 4, 5, and we're done. Okay, these two you both want to estimate before you start, but just to save time. I'd like you to try these two on your own. Okay, for the sake of time, I'm just going to give you the answers here. If you have questions on these, ask me in class, and I will answer them, of course. Whoops, not. I'll do that. If I can type. This one here is 1206.76. And the one on the right is 107.5. This is a hard section, okay? So take your time with it. I know this video was long, but hopefully they won't be as long normally. Okay, you will have a couple IXL things and then a quiz to get. All right, thank you.